I can't hear you. No. Let me check my settings. Yeah, my settings are all fine. Still can't hear you.
Can you hear this?
Yes.
Okay, so it's my microphone.
We're sorry, dear audience.
I'm going to unplug it and plug it back in again.
Mm-hmm.
It might not be necessary. Let's see. Hold on.
Okay.
Okay, I switched. Now can you hear me?
Oh, yeah, and you suddenly sound quite awesome again.
Okay.
Do you know what the problem was?
I hadn't unplugged it and plugged it back in again?
Technology at its finest.
It's funny. My kids constantly were coming to me and explaining to me their technical difficulties. I can't get this Minecraft server to work. I can't, this game isn't working. This microwave is broken. And this car won't drive. So my instructions to the children is the 3 R's, right? Like retry, restart, reboot. And they have gotten, and they know that if they come to me with some technical problem and they haven't restarted their computer or whatever is the device, I'm not going to help them. That there is no help until they actually literally turn off that phone and turn it back on again. And that is now, they never come to me for technical support. So if you're a parent and you are the primary person for technical support, or if you're the all your friends and family are coming to you, just have them turn it off and turn it back on again. It just solves all the problems. So cool. So if you have no idea what this is, we are going to be doing a live episode of Astronomy Cast, our long-running show about space and astronomy. We'll take about half an hour or so to do the show, and then we will stick around for your questions. But before we get onto that, Pamela, people are dying to know. Have you seen Interstellar yet?
No, and after seeing Phil's review and basically the only review that I've seen that was positive was from someone who will benefit financially from the sale of his books. So I consider it a biased review.
Mm-hmm.
So life is very short, and there's a lot of superhero content waiting to be watched on Hulu that I think I'm going to give catching up to Agents of S.H.I.E.L.D. priority over Interstellar.
Well, if you check it out, though, Phil actually did a mea culpa, and his math was wrong. So all of the relativity stuff, all of the black hole stuff, and I don't want to give any spoilers, but all the stuff that he had concerns with actually all turns out that the math was pretty solid, that it was, and so if you check his review of the mea culpa, although there's still all kinds of other issues, and yeah, I didn't love it, and but I was entertained. It was fun. It was fun. That's all. It was fun. There was no Batman. All right, well, let's go, or Inception. All right, let's get cracking. So, are you ready for the recording?
I hope so. I have the software. I have the software in mono. I have the correct mic.
Mm-hmm. Press it. Press that button.
Okay. I'm gonna press the button. I pressed the button. It's doing the thing.
Oh, mine just. Okay, hold on. I have to restart my recording software now, because I think when I unplugged it and plugged it back in again, it was not happy. All right, I'm gonna try again. Yeah, it's recording for me now.
Okay.
Whew. That was close. Pretty dicey there. All right. Astronomy Cast, episode 357, Vera Rubin. Welcome to Astronomy Cast, our weekly facts-based journey through the cosmos, where we help you understand not only what we know, but how we know what we know. My name is Publisher of Universe Today, and with me is Dr. Pamela Gay, a professor at Southern Illinois University, Edwardsville, and the director of CosmoQuest. Hey Pamela, how you doing?
I am doing well, and this is going to be one of those episodes where the lag is highly variable. I feel like we're part of one of those theoretical papers where the speed of light changes throughout the history of the universe, because we keep going from zero lag to like a second of lag and back to zero. So we are clearly caught in the land of timey-wimey.
Timey-wimey, that time is relative, and one day in Edwardsville is 7 years on Vancouver Island.
Yeah, I think it's more like a couple minutes of difference, but yeah.
Did you know, interesting fun fact, that you can be off by about 30,000 years in the universe in time based on all the motion and speed and relativity?
What is off by 30,000?
In other words, if you've been moving really, really quickly, like not like in the region of a black hole, but different parts of the universe as they've been expanding, give or take about 30,000 years in terms of relativity from each other.
That's kind of cool.
Isn't that cool?
Yeah.
Okay. So it's time to do another series. And this time we're going to be talking about famous female astronomers, modern famous female astronomers, starting with Vera Rubin, who first identified the fact that galaxies rotate too quickly to hold themselves together, anticipating the discovery of dark matter. So this is really cool. So we've got 5 or 6 astronomers.
So far, more may be added to the list. That's just where we've gotten to at this stage.
Yep. I think, have we not, apart from like Carolyn Herschel, have we talked about any female astronomers?
And the thing is, we've had this hard and fast rule up until now of only discussing only discussing human beings who had spacecraft named after them.
Yeah.
This is why we haven't discussed Carl Sagan, is the dude doesn't have a spacecraft named after him.
We're breaking these rules now.
We're going to currently break these rules, and the reason we're doing this is because people don't know that there's like modern excellence in astronomy. And so like the recent Cosmos series didn't highlight living people all that well. Astronomy textbooks always highlight the women at Harvard before any of us were born. And there's all of these amazing women. And with everything going on with Gamergate, everything going on in the science communications community, bringing to light how rarely women's work receives accolades. It was like, well, expletive, these women are never going to get spacecraft named after them, so let's just talk about them anyways.
Well, right, but I think it's great to talk about some of the modern people. I mean, there's some people in here who you may not have heard of,
yeah.
But I think we're going to be wrapping up this first set with Carolyn Porco, who is one of the most influential planetary astronomers out there, and responsible for the Cassini missions.
Yes.
Imaging. So she's a force, and definitely stands toe to toe with any modern astronomers out there. And so I like this idea of covering modern astronomers. So I love the idea of focusing on some of the women, and I love the idea of looking at some modern astronomers. So I'm fine for us to throw our rules now that we've sort of caught up with all the astronomers who have missions named after them, and start talking about people who just either living or dead, but especially those people who are making a difference right now, and so I think it's great.
And at the time that we came up with the list, they were all still alive, and despite my recent ability to partner with things that don't stay alive, I'm hoping they all stay alive.
Right. Yeah. Some of them are pretty old. So, okay. Well, let's talk about today's topic then, Vera Rubin. And this is a huge one.
Yes, and this is the story of one of those women who has just consistently done kick-ass, amazing, ahead of her time research that everyone sort of went, meh, no, can't be right. Meh, Vera sucks, eh. And then a few years later, like, oh crap, she was right. And this keeps happening to this poor woman. She does amazing and awesome science, Everyone makes fun of it. Some dude recreates it, and it's proven true. And that sucks.
So, well, let's. So, I think before we go, I think normally we go into their history first, but I'd like to know just sort of like what is the big contribution if if you are trying to think about a field of astrophysics, about astronomy that we talk about, what is the big contribution, the biggest contribution that Vera Rubin has won, the one that you should really remember?
She has two that are tied, because she's just that awesome. The first one is that clusters of galaxies aren't just this happenstance grouping that is all spreading apart as the universe expands, but rather galaxies and clusters are all orbiting a central point to that cluster of galaxies. She was the first person to figure this out, to figure out that clusters do have this center that things are flying around.
Okay, so hold on. So where Hubble looks, he's flying away from us. They are flying away from us, and the further away they are, the faster they're moving. But they're also in these big structures that are rotating and interacting and such.
So if you look around the sky and you grab like 20 random galaxies that are near enough to get good spectroscopy of, which is kind of where Vesta Slifer, who took the data that Hubble originally used, did. Those groups of galaxies, they're just going to be randomly moving away from us at rates that depend on how far away from us they are. But if you do entire systematic catalogs, you're going to find clusters within that catalog of galaxies that are all moving away from us at the same collective rate, but within that group they're going to have orbital rotations that spread them out, as another woman that we're going to talk about later, Margaret Geller, figured out. But Vera Rubin was the first one to start figuring out that galaxies orbit about a central point.
Cool. Okay, that's one.
Okay.
What's the second one?
That galaxies have dark matter.
That dark matter is a thing.
It was hinted at earlier by Zwicky, but Zwicky is someone who falls into the, if you are too nasty of a person, people don't like to listen to you, so they don't listen to your science either.
Oh, no. So he had some personality problems, too?
Yeah. Well, right. Vera didn't have personality problems. She's actually, by all accounts, like the sweetest, nicest human being ever. Zwicky. Zwicky had personality problems.
Yeah.
But she came along, and while doing research to study galaxy rotation curves, she was partnered up with an instrumentationist, Ford, and so she's using all of this brand new instrumentation. She's looking at the rate at which stars orbit galaxies as a function of the distance. I realized, well, this doesn't fit with what you'd expect given Newtonian physics if we can see all of the stuff that has matter. So the idea was, when you look at galaxies, all of the light coming from stars is focused in the center and tapers out as you move out, and you would expect, if your orbit is determined by how much mass is inside of your orbit and your distance from that center of mass, that as you get further and further away from the centrally concentrated mass, your orbit's going to slow down. That's what you'd think. That's what matches Newtonian physics, if you make the assumption that all the stuff that has mass also is happily giving off light of some sort. And she was the first person to figure out that that is seriously not the case. And over time, people started to figure out, well, there's hydrogen gas, but there's not enough of this not glowing hydrogen gas to make up the difference. There's this other dark stuff that we can't really make out, but there's not enough of it, like dark molecular clouds and stuff. And in the end, it came down to, there's stuff in these galaxies that is dark, that we're going to call dark matter, that is driving the rotation curves of galaxies.
And so if they didn't have the dark matter, wouldn't these galaxies be kind of tearing themselves apart?
Because of the measured velocities that she found. The stars in some cases were orbiting at what should have been escape velocities, so that instead of continuing to spiral around the galaxy, you're looking at a snapshot of a star that's getting ready to move in a straight line or just arc, and not stay associated with that galaxy. So yeah, those galaxies were totally filled with associated high moving stars, and that meant that there was a whole lot of stuff that was at a entirely different non-existent luminosity.
Right. And it would be like I'm trying to think of a good analogy, right? It'd be like watching I don't know, say a star going around a black hole, or a star whipping around around this black hole, and you're like, man, that star should really be flying off into space. Oh, it turns out it's a supermassive black hole, not a regular massive black hole, right? That's the trick, because you can't really you can't see the difference between a supermassive black hole and a regular black hole. They're not there.
Well, they're kind of in different locations, but yeah, that's a different.
Yeah. But it's the effect of the gravity, right? So okay, great. So now those are the two things to hold in your mind, that galaxies are collecting into these gigantic structures and orbiting a common center of gravity, and dark matter itself is out there. So let's go back then and let's talk about Rubin's history. So where did she go to school?
She's someone who just throughout her entire life always astronomy, and she started out as many young women of her age did. She went to Vassar. She got an excellent education. After going to Vassar, she was hoping to go Ivy League, as one who's brilliant hopes to do. In her case, she was hoping to go to Princeton, but Princeton didn't exactly allow women at the time. So since the doors to the education she wanted were literally closed to her because she was a female, she instead went on to get her master's degree at Cornell University, which is still a completely awesome university. It's not Princeton. So she went on, she got her master's degree at Cornell. She went on to do doctoral work at Georgetown University. Did excellent work the entire time. It was while she was a graduate student working on her dissertation that she figured out about galaxies clumping together and figured out about them rotating around a central point. But despite the fact that her dissertation work was really a pivotal moment for extragalactic astronomy, people kind of just discredited what she did. She ended up going on to get a job at Montgomery Community College, or rather Montgomery County Junior College. It wasn't even a community college. While she was there, she didn't want to walk away from research. Let's face it, you're a woman who's been fighting as long and as hard to do research as she has. It's kind of hard to just step away. So you find ways to do research. So she got a position as a research assistant, not even a research associate, a research assistant at Georgetown University. While she
how is Georgetown known for its astronomy?
It's okay. It's not great. You don't generally hear about cutting edge research that is pivoting the way our field thinks coming out of Georgetown. You get good astronomers there. You get solid astronomers there. But it's not someplace that you expect someone doing pivotal work to end up with the lowest possible title that you can give someone doing research. So while she was there, she continued trying to do research. She was eventually hired on as an assistant professor in 1962. It took her some time. And at that point, she needed to use bigger and better telescopes to keep doing her work, and she ended up becoming the very first woman authorized to use Palomar telescope. So here she had to jump through hurdles of women weren't even allowed to get time on Palomar, and at this point she's an assistant professor at a perfectly reasonable university doing breakthrough research. And they're like, but you're a girl. You can't use this scope. Oh, I guess we'll change the rules.
Right. So they changed. So they changed the rules about who can use the Palomar Observatory to
Yes.
to allow her to do her work.
Yes. Yes.
Right.
How gracious of them.
Yeah.
Sorry for the sarcasm dripping.
Yeah. No, I think we need to prepare everyone that there is going to be mountains of sarcasm dripping through this entire episode and probably the entire series, because this is going to be a theme that is going to definitely run through a lot of it. And fortunately, all those problems are over now, he says, being more sarcastic. But I don't want to poke that bee's nest yet.
Yeah.
So let's keep rolling. So okay. So you got access to the Palomar. Now, where's Palomar located?
It's outside of Los Angeles.
Right. Okay.
So it at the time was probably, if not the best, one of the best telescopes that she could have access to in the United States. Amazing facility, great telescope. And with it, she continued to do awesome work. This is where she started working with Kent Ford. She actually went on to get a position at Carnegie Institute of Washington, where she was able to continue focusing more and more on research. She didn't have to split her time quite so much. And she's still at Carnegie, actually. She's there as a senior fellow, so she never ended up with that golden ticket of being a tenured professor, but a senior fellow at Carnegie, still an extremely prestigious position.
And it's fairly famous for its astronomy.
It is a top institution.
Yeah.
She was, over time, finally able to get her work acknowledged for the excellence that it was. But it did take time. Her work with Kent Ford on galactic rotation curves is now something that we make part of pretty much every freshman astronomy course at a university that has even the smallest of radio telescopes. We make them replicate the research in the radio. But despite the fact that
That's cool.
It took a long time to get people to accept that this was just the way things are.
But that's amazing. That's really awesome to me that you guys still do, that you'll have your students replicate that data using their, replicate that data using the instruments that you have available, using radio and stuff. That's just so cool.
So she went out and she looked at stars, at luminous matter, and did this for galaxy after galaxy after galaxy. With our students, we just have them look at our own galaxy and look at the clouds of gas out at the outer edges of the galaxy. And so it's a much simpler project, but it's getting at the heart of what she did. And so starting in the 1970s, people finally, 20 years after she'd started all of this, started to recognize all of her work as being as influential as it is. And over the years, she has gone on to have amazing students. Sandy Faber, who we're going to talk about later in this series, was one of her graduate students. She went on to receive notable awards, but there are several people who are like, why didn't she get a Nobel Prize? Because one of the big criteria for getting a Nobel Prize is doing work that observationally demonstrates that something exists. And she did the observations that demonstrated that dark matter exists in galaxies.
And we just saw, just a couple of years ago, right, the award of dark energy, of the Nobel Prize for Dark Energy, which again, we don't know what dark energy is. We probably know even less about dark energy than we know about dark matter, and yet a Nobel Prize was awarded for its discovery, but not its identification.
Right. And so going down the list of awards, like one of the most disturbing ones for me was she is the gold medal of the Royal Astronomical Society, and she was the second woman to get it, and the one before her to get it was Carolyn Herschel in 1828.
Right, so like 150 years
Right.
earlier.
And there's all sorts of examples throughout her history of being the first woman, the second woman, the third woman to get these long-term awards, and she did some of the most amazing work. She deserves every single one of the awards, but the fact that there's so few women's names on these lists was really brought home to me looking up her history. Because it would be nice to think you didn't have to do work worthy of a Nobel Prize that no one bothers to give you in order to be one of the only names on a list of awards that don't usually go to people deserving of Nobel Prizes.
Right. So there you are.
Yeah.
I mean, I think that this is going to be the theme, and I just need to warn people in advance. The theme is going to be that what we're going to hear again and again and again is legitimate, high quality astronomy work, unrecognized, kind of pushed, kind of had to be proven beyond a shadow of a doubt before the naysayers started to sort of accept the validity of it. I mean, and not so much with some of the more, like as I said, with Carolyn Porco and stuff. I don't think anyone is gonna say that Carolyn Porco isn't doing great science.
No,
and she would kill them if they did. So.
Yes, and that's the big difference between Vera Rubin and a lot of women that we're going to discuss. Is Vera is someone who's simply done absolutely amazing work with a reputation for being the sweetest, nicest human being on the planet. Every picture I've found of her, she's either has this expression of complete absorbed in what she's doing in a positive way, not with the I'm completely absorbed in what I'm doing and look like I'm going to scowl, but just this I'm focused and absorbed and joyful, or she has this sweet smile. Just there's this pleasantness that comes out of her where one of her most frequent quotes that I'm trying to find on this page, so I can't find it, so I'm just going to paraphrase it, is fame is fleeting, science is forever. That's a paraphrase of what she wrote, but that's just such an amazing concept. And she was invited to go back to her one of her alma maters, University of California, Berkeley, and gave a graduation address there. And one of the things that she said, and I think I'm going to be very controversial and say I like this quote better than Carl Sagan's version of this quote. She said, "You drank the milk, the carbon atom entered your bloodstream, traveled to your brain, displaced a carbon atom, and took part in the thought process, permitting you to pass your final exam. So without that single carbon atom, made in some star billions of years ago, you might have failed to receive your diploma today. See how lucky you have been?" I just love how she gives it so much more of a picture.
Mm-hmm.
And it's really worth looking up the graduation address she gave. Most of it is on the website brainpinkings.org, and we will link to it in the show notes. It's just chock full of amazing things. She also goes on to chide the students in the audience who are going to go on to teach science to make sure that they didn't focus all of their efforts on the students who are going to be scientists. Because, as she put it, we need senators who have studied physics and representatives who understand ecology. To her, it's always been as important to teach the non-scientists to be knowledgeable as it is to teach those who are going to go on and follow in our footsteps and become the next generation of scientists.
So we talked about her big discoveries on astronomy, on the galaxy rotation problem, dark matter, the work with Ford. What other kinds of projects did she work on? I mean, Such a
Her
long career, right?
Right. Her entire career has continued to be focused on the study of large-scale structure of the universe and galaxies and galaxies within clusters. So this is a field that, even though I can say quite flippantly, scores of years ago, she's the one who figured out that there's this universal galaxy rotation curve. That work is still going on. That work is still being refined. Galaxy cluster information, that's still work that's being refined. So these aren't solved questions. They're questions where she discovered the question exists.
Yeah. Huh, that's funny. That classic that classic quote, right? Huh, that's a little weird.
Exactly.
Right? Yeah. And so where are we, what is the current state of the art in that? What are the big still kind of unsolved questions in this idea of this galaxy movement?
I think right now with the galaxy movement, we are still trying to figure out, are we certain there isn't an extra term to gravity that we need to take into consideration? And beyond saying we know there's a dark matter particle, end of statement. We know there's a particle. We don't know if there isn't also a extra term to gravity.
Sorry, when you say an extra term, do you mean sort of like this Mond idea, right?
Modified Newtonian dynamics.
Right. That over long distances, maybe gravity acts differently than it does.
You need to add an extra term to GMM over R squared. So we do know for certain, though, that there is a particle form to dark matter, that it is most likely non-baryonic, which means that it doesn't like to interact with stuff the same way neutrinos don't like to interact with stuff, and that it doesn't interact via the electromagnetic force. So it's going to have absolutely nothing to do with light other than bending it with its own gravity. Now, there are arguments in the literature over whether this is a weakly interacting massive particle or something else. There are hints that maybe we haven't found it in large particle accelerators. But I think that if CERN gets another good season of running, we're going to start to be able to get theories either eliminated or confirmed for the lowest weight, most reachable of these weakly interacting massive particles. So there is hope there. There are people working very hard using these underground neutrino detectors that can also perhaps be used to look for interactions with some of these stray particles that don't want to interact with the electromagnetic force. And as we look further and further back with James Webb coming in our future, one of the lasting questions is, how did these galaxy clusters evolve? Many of them have these massive central galaxies called CD galaxies that are structurally something very different from your normal run-of-the-mill elliptical. When did they form? Was this a group of a bunch of galaxies that flowed together? Was this a matter of overdensities in the dark matter that drew in not just a massive galaxy, in all of the stuff that would fragment into galaxies? Or was it both? So we're still trying to sort out the not just top-down, bottom-up theory of galaxy formation, which we're now pretty sure is mostly fragments coming together to form bigger and bigger, except in some cases of ellipticals. It's that except that is fascinating. But we're still trying to figure this out for clusters as well. Was it all local group-like things coming together to form bigger and bigger clusters? Or did you occasionally start with the supermassive clusters as well?
Well, and here we are, 50, 60 years after this discovery, these initial discoveries were made, and still we haven't, completely nailed down all these questions. It's amazing how long this process takes, even with the modern tools. I mean, they've dug up half of France and Switzerland to make a gigantic super collider,
If
and
only it was half of France and Switzerland, then we
France of
might have
Switzerland.
solved
Yeah,
this
yeah.
already.
That that's all it took, and we still haven't quite got to the bottom of these. We found the Higgs boson, but not the rest of it. So yeah, I think it's great. Okay, cool. Well, thank you very much, Pamela.
Thank you.
Look forward to next week.
Thank you.
Let's
Okay.
this up.
Saving recording. Stopping recording first. It'll save better that way.
As I said, 357.
Yep.
Export. Thank you for clearing up the Dropbox.
Oh yeah, sorry about that. I was in grant writing hell, and so I was hiding from the people who normally go, "Hey, what's written on the back of your hand?" triggering me to go, "Oh shit, I forgot to do that thing."
Right. All right, and let me just check and see where we're at with the Q&A. So I just want to give people one announcement, and this is something that you're going to want to just be aware of. Currently, the Astronomy Cast comes from my own personal YouTube channel, and this is kind of a legacy because in the olden days, brand pages on Google Plus couldn't run Hangouts on Air, and then later on they could run Hangouts on Air, but very poorly and without access to a lot of the tools that we needed. But now it's all there, I think. And I know you guys run a lot of the stuff for CosmoQuest, Learning Space, etc. That's all through CosmoQuest. So we're going to shift Astronomy Cast from running from my personal YouTube account to the Astronomy Cast YouTube account. And so if you haven't already, make sure you subscribe to Astronomy Cast. Is it on Astrosphere Vids?
Yes, everything is on Astrosphere Vids. It sometimes takes a few days before Richard gets to it, but Richard is awesome and gets to it eventually.
Yeah. So, but if you want to like if you want to watch the video, the full YouTube video, now we'll embed it in the Astronomy Cast page, and we'll kind of figure all that out. It might not work. It might have to be on the Astronomy Cast site. Anyway, we'll figure it out. The point is, it won't be here. It'll be somewhere else. So, but we'll, I'll try to post I'll post the link over on Universe Today, and we'll post the link into the Weekly Space Hangout crew, and we'll try and make it as visible as possible. But just be ready for that. Okay, and then we'll probably do the same thing with the Weekly Space Hangout. So just be prepared, all. And what's great about it is then it doesn't depend on me. It depends on everybody, or anyone within our team can start up an episode of this Weekly Space Hangout or Astronomy Cast or whatever, and different people can produce it. So hopefully this will make our lives a lot easier. Okay, moving on. Adam Synergy, I don't know if this is a quote. Adam Synergy says, "Does sex matter? Of course it does, but does it matter enough to matter? Capital M, that's a different question." That's Vera Rubin. I don't know if she said that. But it's awesome if she did.
Sorry, you only sort of have my attention because GarageBand crashed on closing, and I'm making sure that everything's saved, and it did.
Guido Bieber says, "I'm still deeply amused by the fact that the microphone in the Astronomy Cast logo has no off-on switch." Our logo, the sort of preparation logo, has no on-off switch.
We have it on our regular logo.
Do we?
Yeah, I made sure of that. Unless it got lost in one of the renderings.
Can't be turned off. So Noel Ruppenthal asks, if the gravitational bending of light is a result of space-time curving, how can a black hole curve space in such a way that a photon going straight out of the event horizon reverses direction? So I don't know what it means by reversing direction, but I mean, you could have a photon fall into the gravitational well of a black hole, orbit it once, like a comet, and come back out the other way, and just go straight out from whence it came. No problem. So, just like a comet, right? Just imagine it's following a straight line, just like a comet is. And that straight line happens to be going through a gravitational well. How did I answer it? Are you still struggling with GarageBand? Or are you
No,
back?
I'm back, and I only caught the part.
So that is all you need to know. Let's, uh-oh. So Nancy Graziano asks, what are your views about reports that the Higgs may not exist after all, in spite of the experimental results coming out of CERN? Have you heard about this?
No.
No, me neither. So Nancy posted a link on Russia Today.
Sorry, apparently the mailman's here.
Yay! Freak out, all dogs. We have no knowledge about this. Will Idoni says Jocelyn Bell should have won the Nobel for sure. And she's on our list, so we'll get there.
Yeah.
What do you think? Would you give her a Nobel Prize? You give them all Nobel Prizes.
No, I mean there's certain names that you look at. Jocelyn Bell Burnell clearly is the person who made that set of discoveries. They literally skipped over her when they awarded the prize down the list of people on the paper.
Yeah. Spoiler alert. You know what? Stop spoiling. Yeah. Let's wait till we do the show, because it's a terrible story. It's the most egregious, I think, of all of these. Anyway, I'm spoiling already. We'll get on that. We'll get there. Stay tuned, everybody. Okay. Renko Prozo asks, what did you guys think of Interstellar?
Oh, you missed the very beginning of the episode where I kind of went, life is short. I've seen bad reviews. I'm catching up on Marvel instead. I watch Agents of S.H.I.E.L.D. I'm behind like 4 episodes.
Yeah. And I thought it was okay. It's all right. So it wasn't super wonderful, fantastic. The imagery of the black hole was beautiful. The imagery of the wormhole was gorgeous. So a lot of the graphics were pretty. The rest of it was pretty weird. So Noel Ropenthal has given us more information. He says, but a photon emitted by some process inside the event horizon directly away from the center of the black hole would reverse direction, like a rocket fired straight up would come straight back down. How could space get curved to make this happen? Just like a rocket going up and crashing back down.
It's the exact same. It's a parabola that is simply very pointy.
When you throw a rock into the air, it is following a straight line in a curved space-time. And that straight line happens to crash it back onto the surface of the planet. So just like that, except for light in more gravity. Okay, you're just nodding, so all right. Well, that's all the questions I think I've got here. Let me see if there's anywhere else. Ilya Sara asks, where can we send live comments? You just did.
Yeah, that's really kind of funny. I love meta comments.
But in general, if you're watching this, you want to click on the Q&A app, and that's where you can post your questions.
Yeah. Yeah. And if you're wondering why I'm distracted, I live just a few miles away from Ferguson, and there was just a fury of stuff on Twitter, and I was trying to figure out, do I need to worry about my students who live there, commute through there, my friends who live there, commute there?
Wow. Eimer Stadler notes, how much of a minority can you be if you have Feynman and Gamow as advisors for your doctoral thesis? So I guess we didn't mention that, but it's totally true. She had some pretty significant astronomers that she either was advising her and then also was collaborating with, including
But there's a difference between getting to work with all of the awesome big boys who take on lots of students and getting the deserved credit for your work instead of showing up to present your work and getting the, yeah, no.
Yeah.
And what you see over and over is you can have women who work with amazing advisors, who do amazing research. When they take that stage and they present their work, they get treated like a dumb grad student who doesn't know what they're doing by people who don't understand their field and just want to basically heckle with complicated sounding questions.
And Feynman is not a man without controversy of his own.
Right.
So,
yeah.
I wonder if we can do a Feynman episode someday.
Right
after the Sagan one.
Yeah.
All right. Cool. Well, I think we're good. I think we should wrap this up while I still am able to talk clearly. So thanks, Pamela, for beginning us on this journey, and we got a few more stops to go before we reach our final destination, which currently is going to be Carolyn Porco. So
okay.
Save the best for last. Anyway, the closest to last, the one that we've both talked to. I don't know if you talked to any of the others on this list.
I've talked to, I think, all of them at one point or another.
Really?
Yeah.
That's amazing.
Virginia Trimble managed to successfully terrify me.
I've only talked to one. No, I've talked to 3 Nobel Prize winners. Saul Perlmutter.
Mm-hmm.
Trying to think who else. Yeah, but I got to do that Sci-Fu convention at Google.
Yes,
There's a bunch of
deeply envious.
Nobel Prize winners kicking around, hanging out by the bonfire, talking about the nature of reality.
I would love to go to Sci-Fu.
Yeah. I wasn't invited back. But apparently you're not. So,
okay.
Yeah, they won't invite you back if you go once. Cool. Okay, well let's wrap things up. Thank you again, Pamela. Thank you, everybody. Prepare for some confusion while we shift streams and feeds around. So if things aren't where you expect them, it's happening. Just work a little harder to find where it's going on.
Yeah.
So I apologize in advance. And if you haven't already, follow Pamela. She hasn't put her lower third there. Star Strider with a Y on Twitter.
It died when you hid me. That's so sad. Yeah, please. I may for the next few days be tweeting a little too much about the riots in Ferguson.
Okay.
But other than that, I mostly tweet.
Yeah, well, you've got some people in the line of fire there, so. Okay.
Yeah, no, we do.
Okay, cool. We'll see you later.
Bye-bye.
See you, everyone.